Okay, so I said that I would try to do something for parametrics and speed. I'm not sure if this will get to you on Wednesday or not, but if it does not get to you during school on Wednesday, I'll make sure that it's posted on Edmodo, or you get to see it on Thursday. Lyman kids, hopefully you'll have checked maybe Facebook, or maybe maybe when you can put this link on Facebook if they don't see that on Edmodo, maybe y'all can put it to y'all's class page. That'd be great. So, thanks a lot, guys. When we're talking about speed of a particle, on the last thing we were talking about the arc length in parametrics, and we did the square root of the derivative of the x part squared plus the derivative of the y part squared. And if you think about that, it kind of makes perfect sense for that to be speed. You physics students may even have a better idea for this, because this is kind of what you've been doing. If you think about it, you've been thinking about how fast is something moving in the x direction, how fast is something moving in the y direction, and then can you find the resultant vector? And really that's what this is asking us. We know how fast it's moving in one direction, we know how fast it's moving in another direction. Can we basically turn this into a right triangle and do a Pythagorean theorem type situation? So I have an example here, and we're going to see if we can, first we're going to get the equation for speed, and then I think I actually have a spot that we're going to see if we can find it when time is 3 seconds. So our speed of our particle is going to be found by the square root of this derivative of x, so it's going to be 2t squared plus the derivative of the y, which is going to be 4 cosine of 4t all squared. So that's the equation that we would use to find the speed, and to get the actual speed we would plug in the 3 for time, and we would get, let's see, 2 times 3 is 6, squared is 36, plus 4 cosine 12 all squared. Now, we would need a calculator to be able to calculate this, so let's see if I can pause this and figure it out and then get back to you. Alright, so that is going to be 6.884. Alright, so make sure you've tried that in your calculator and you get the same kind of result. But this is basically what speed is. So it's very, very similar to the arc length formula. The only difference is arc length had that integral in the front going from A to B, so we actually had to integrate our result. But in terms of speed, we are just going to oftentimes have a time value that we want to find the speed. Okay, so let's see what other kinds of problems we can do in terms of this. Okay, so this is the other problem that is on this note card, and I'm just going to kind of talk about it instead of work out the problem, because you can see over here that it's calculator based. But what's really important to realize is that this is from an old free response question, and it is telling you that they've given you functions for position for both the x and the y, which is what these parametric equations have been doing. They tell you that it's measured in meters, and then they give us, actually very kindly and also a little strange for the AP exam, the derivative of both of those two functions instead of actually making us do it on our own. So this is probably letting us know that they had made you spend a lot of your time doing some other thing in this problem, and they didn't want you to spend the time to actually find the derivative, or maybe they just decided that those derivatives were way too easy to find, so they were just going to go ahead and give them to you. Either way, very surprising that they did this. Okay, and then the part where they're actually asking the questions down here at the end says find the time when the car is at its maximum height. So maximum height, to be able to determine this, we need to kind of think about this very carefully. Okay, so remember the velocity in the x direction, that's going to be talking about its horizontal movement, so it's movement left and right, and the y prime, the velocity in the y direction, is talking about its movement up and down. And so if we kind of think about these two things, we'll try to find out when it's at a maximum height. We're really kind of talking about when is its position in y the highest. And if you kind of think back to good old AB Cal, the way we found when something was at a maximum was we took its derivative and we set it equal to 0. So if I'm trying to find out when something is at a max vertical height, what I need to do in this situation is take the derivative with respect to y, which they've already given us. It's right here. It's 20 minus t times sine of t plus the cosine of t minus 1. And I need to set that equal to 0. You can see that this is a calculator question, so you're going to do this in your calculator. Okay. In fact, if it were me, I would not use my solve feature for this. I know that that is a intriguing thing to try, but it is not your best bet. This graph over here is another thing that will help you, because what you're going to actually end up with is this is showing us this graph is showing us the motion of this particle for the first 18 seconds. I know that's not clear from this graph, but this graph is actually trying to show us the motion of this roller coaster for the first 18 seconds. Okay, so over here on the y-axis is our height, over here on the x-axis is our distance left and right. And if you notice, our maximum height is occurring at this very first instance when the derivative of y is going to be 0. So the very first peak is our highest point. After that, it gets progressively smaller. So we're actually going to take that derivative, set it equal to 0. I'd graph it, and I'd take the very first spot where we cross the axis going from positive to negative to be my maximum, the time where I have the maximum height. They didn't actually ask me for the maximum height. I could actually find it by taking that time and plugging it into our y function, but they did not ask me that. In fact, I could actually find my total position by putting in that time into both the x and the y and kind of getting an ordered pair. But then the thing that they did ask me to find would be the speed of the car at that time. So once we found that time, they were asking us then to use that speed formula that we just looked at to be able to determine the speed of this car at that time. So let me show you all real quick what the answers are to this. The answers for this is the maximum is going to be at a time of 3.023 or 3.024 seconds, depending on if you round or truncate your answer. And then the speed, depending on which time you use, will either be 6.027 or 6.028 meters per second. Units do matter on these problems because they gave us units in the stem itself. Okay, so I hope this gives you a really good idea of what speed looks like for parametrics.